Hey everyone, today I'll be doing a Leetcode Biweekly contest 71. I haven't been doing so good recently, so hopefully I'll be doing better this contest. The last few contests, I've just suffered a bit because of constant optimization, but hopefully that changes today. I'll go through the solutions at the end as well, and wish me good luck. Min possible sum. And these are 52 and 13. I'm just going to think about that one a little bit. So I'll just leave it there for now. Alright, that one got AC. Right, I got AC. What? Oh, okay, this is an interesting question. Okay, 4 minutes. 0 up to 100. Target. Minus minutes times 60. If 0 or s is greater than 99, I'm just going to continue. M divided by 10, not 10 is divided. That's our pos. If I is not equal to pos, then we set up current position. Alright, that's 6 and 6. Six and 10. Why is it 10? Alright. 0076. Oh. Okay, I understand now. So I can ignore zeros. Like that. Alright, I got AC. Alright. Minimum difference. This seems hard. Like there's an obvious ON squared dp, but no, I'm not quite sure how to do this one, I'll be honest. Oh, okay. It seems sort of greedy to me. Equals salt. Okay. Oh, okay, I'm stupid. I, okay, I understand what I'm doing now. Do I days? Okay, I need a data structure that always keeps the nth lowest, some of the nth lowest things. Okay, now I need to iterate over all splitting positions. Oh, that doesn't look right. All right, some print debugging. Okay, that's really weird. All right, that's a bug. All right, that might be good enough. Nope, it's not good enough. I want -14. That? All right, that's better. What? Unknown error? Rate limit exceeded, come on. Please. I see, okay. So I'm not quite sure how I did, but I'll go through the solutions now anyway. Okay, for this problem, basically let's say that the 4 digits are A, B, C, D. For example, if we split this into, let's say we're trying to split this into two-digit numbers. Like for example, let's say like we have like 3, 1, 4, 8, and then we want to minimize the sum of two-digit numbers where we can permute these digits inside this answer. Well, in this case, this sum, the 3 and the 4 are currently in the tens digits, and then the 1 and the 8 are currently in the units digit. So this is how the sum can also be expressed. i.e., if the digits are A, B, C, D, we want to permute the digits such that 10 times A plus B plus C plus D is minimized. And that's essentially what I'm doing here. First, I'm getting the 4 digits, I'm sorting them, and because the A and the B are kind of worth 10 times as much, we want to greedily make A and B the smallest of these digits. If you have some numbers such as 8765, we would choose 57 plus 68 or something along those lines, so that I get this sum. And you can do the other cases because it doesn't have to be two two-digit numbers. You can do like a 1-digit number, a 3-digit number, but you should be able to find that the 2-digit numbers will always be as good as the 1-digit and 3-digit. So there's no need to consider that case. All right. Here's this question. Oh, okay. So this, I didn't like put, all of this wording just went over my head. I kind of just studied the example output and that was good enough. Basically, I have 3 arrays. The first array is for elements, which is less than pivot. The second array is for elements which is equal to pivot. And the third array or list is equal to elements which are greater than the pivot. So all I do is I loop through my numbers, I put them into the corresponding list, and then I just concatenate those lists, and that's my answer. This was a pretty boring question. I actually think this required more thinking than question 1. Anyway, time to look at this question. Okay, so this question is interesting. And let's just say, I'm going to say target seconds is, let's say target settings, target seconds, sorry. Let's say the target seconds is 258. Now, if I know that there is 0 minutes on the, let's say I know that there's 0 minutes on the clock, that means I need to represent this as 0 minutes and 258 seconds, which clearly isn't possible because 258 doesn't fit. Or I could express this 258 as 1 minute and 198 seconds. Or I could represent it as 2 minutes and 138 seconds, and so on and so on. And basically, all I'm doing is, if I know the number of minutes, I can get the remaining, I can work out with math how many seconds there needs to be on this clock. So all I'm doing is I'm brute forcing the number of minutes, and based on the number of minutes, I can work out the number of seconds. That's just the total number of seconds minus the seconds which is contributed by the minutes already. And if this is less than 0 or greater than 99, that means it's not going to fit into the microwave. So I don't need to consider those. So everything after this loop assumes that I've already found an M and an S, where M represents the number of minutes I'm going to put on the clock, and S represents the current number of seconds I put on the clock. Okay. Basically, the other thing which I didn't notice until I looked at sample output 2 is you don't need, if it starts with a 0, the microwave will automatically prepend zeros, which means that, let's say your microwave time turns out to be 0060, that means that I don't need to manually I don't need to manually push these 2 leading zeros. So what I'm doing is, first of all, this list stores the digits that would be in my clock. For example, if I knew that there was 3 minutes and 40 seconds, then the microwave would display this, and would display something like 0340, and my current list L would store 0340. So L is currently just getting the digits, which is going to be showed by the microwave. But what I want to do is I want to ignore the prefix of L, which only consists of zeros, because those are the leading zeros, which I can ignore. So basically all I'm saying is, while the current position I'm up to is 0, I'm just going to increment this position, and therefore everything in list L from X onwards, so those are the digits which I actually have to punch in, and anything before it I can ignore because they were, I can just ignore them. And then it's pretty simple. For each digit that I do have to push in, if my hand isn't already there, then I need to move my hand and add in the move cost, and then when I press the button, I at the push cost. And then all I'm doing is I'm just taking the minimum over all possible minute-second combinations, and there's at most 100 minute-second combinations because each combination is uniquely determined by the number of minutes, and there's at most 100 minutes. Okay, this question I kind of threw a little bit. I'm really curious to see what my score is, but I guess I'll do that afterwards. Basically, the whole thing about removing it's really inconvenient to think about removing n elements because it's hard to figure out where stuff is partitioned. Instead, we're just going to focus on the elements which are not removed. If in my final list of 2 n elements, I know that the first n elements belong to the first part, and the last n elements belong to the second sum. And that means that all of the elements belonging to the first part will appear earlier in numbers, earlier in this list, than the elements in the second part. I.e., that means I can take this numbers list, I can chop it in half. There is guaranteed to exist a partition such that the first sum only consists of elements in my left half, and the second sum only consists of elements in the right side. And let's say, for example, I decided that my partition was going to be here, i.e. I need to choose 2 elements in this first part for the first sum, and I need to choose 2 elements in this right half for the second sum. What I would do is I would just take the n smallest elements in the first half, in the left part of the partition, and I would take the greatest n elements in the right part of the partition because that will give me the smallest possible difference. So all I need to do is if for any position in the left half, if for any position in the left half, I can find the sum of the n lowest elements quickly, and then for each suffix of this nums array, I can find the maximum possible sum of n elements in that suffix, then I will be able to solve this problem just by brute forcing over all partitions, and then when I get to a partition, I'll use my lookup arrays. I would have pre-calculated the minimum possible sum in the left part and the maximum possible sum in the right part, and then I'll just take those differences. And let's just focus on the left part for now. We need to find for each prefix, we need to find the n smallest elements. And this is basically what this function does. So this function takes in a vector of numbers, and for each prefix, it'll add to our output for each prefix the minimum possible sum of x distinct elements. And basically, let's consider an example. Let's say, let's consider this example with n equals 2. When I get to my first prefix, currently we haven't considered any elements, so I would have to take this 7, and then I would have to take this 9. But when I get up to this third prefix, I see that this 5 is better off than this 9. So what I would do is I would kick out this 9 and put in this 5. And then if I got to this 8, so I would store, what I'm doing is basically, for each prefix, I'm keeping a list of the x fewest elements which I have so far. And anytime I come across a new number, if that number is less than the greatest number in the list I've seen so far, I would replace the highest number in the list that I have so far with the current number. And basically that's just what this is doing. So basically if the largest number in my list is greater than my current element, I'm going to replace the top element with our current element because that will give us a lower sum. And of course, if there aren't x elements yet, I'll just add it to our list. And we need a data structure that can efficiently check the maximum in a list and remove the maximum. And I can just do that with a priority queue. So that's basically how my answer function works. And then for the right-hand side, it's exactly the same. Instead of it's literally exactly the same. So much the same, in fact, that I have just reused my implementation of the same function. I've reused it by reversing the list and negating each element, and that's because maximizing the sum of a suffix is equal to minimizing the sum of the prefix when I flip the thing and negate it. And then in this part, all I'm doing is I'm brute forcing over all partitions, and then I just use my lookup arrays. I'll take the sum of the first part, and I'm going to subtract the sum of the second part. The reason why it's plus here is because I negated stuff. Then since I'm solving B with the negated array, then the negated part is already implicitly in the array B, so I add it instead. And then I just take the minimum over all partitions. Okay, so now that I've done that, time to see how good or bad I did. That's not bad. It's rank 8 for now, but obviously that could have been done a lot better. Anyway, I'll see you guys next time, and thanks for watching. Remember to like and subscribe if you haven't. Alright, see you guys.